there, this is Alex, and I am here today with a Dom IX SR, also known as the Saturn. This is a dimple lock, 5 pins I believe, with at least one active element and some other fun security features that we'll get to explore in a bit. The one that makes it the SR or the Saturn is this little disc here. So it has this little disc here. Grab it. There it is. It pops up. Goes back down. So this activates some kind of pin that I believe interfaces with a sliding sidebar. And from the diagrams, it seems like there might also be one on the side. Okay, after a lot of difficulty, I got the circlips off, so here's the Okay, so here are the pins, and this is one of the most evil sets of pins I've seen in a while. So 5 pin stacks. We have, I would call that a serrated driver. I would call this a, I don't know, super spool. Another super spool, another super spool, another serrated driver. Hopefully you can see the little ridge right here. It's going to catch down inside the chambers, which are not counter milled, thankfully. Then our bottom pins, our key pins, the mushroom, and that's steel. You can see it wanting to stick to the tweezers, which have been mildly magnetized unintentionally. There's another steel mushroom, a little bit shorter. And then I was very surprised to find 2 pins in position 3. This is a spool, little bitty spool, and then a normal pin. I'm going to call that a master wafer. In this particular bitting, they both need to be in the down position. So, but in principle, you could set it higher, but that's going to want to bind nicely. And then 2 normal pins in the back. One deep, 2 not as deep, 3 deep, 4 very shallow, 5 deep. Okay, pretty unpleasant. Now, if we look at the key a little bit more, we'll see a bunch of other features on it. First of all, there are some dimples here. These correspond to these little pins here, and I'll show you what they do in a minute, but basically they set down in these dimples like that. So if it's here, it sets up, and if it's here, it's down. And there are 4 of those. Good. 1, 2, 3, 4. And then, get underneath, there is the Saturn ring. So you can see that moves. I'm not doing a good job of pressing it up, but that pops up when it's appropriately jiggled. There we go. And that rides on a ward. That, my very adept description of that pushes up on this pin, and you can see it's a little bit pointy on the end. Okay, And we'll show you what that point does in a minute. Okay, and that's the active element. Then it gets better. There are all these little cutouts in the side of the key here all the way along, and you'll notice that one of them is a little bit different. It's a little shallower. That interacts with a ball bearing, and there could be more than one of them. I'll try not to drop this on the floor, but depending on where this is located, it either goes in or out. Okay? So those are all of the moving parts, sort of that interact with the key. So here you can see there's a groove at the bottom, and there's a groove on this side. So we have two sidebars, both of which are active, sort of. Okay, now let's look at the plug. So here's the plug. This is the top surface. Looks pretty normal. 5 pin chambers, drill pin here, or anti-drill pin here, hardened steel, I would presume. I'm now going to rotate it to the, so we're going to call this the 12 o'clock position, the top. Okay, I know that these are mounted upside down, but just for the orientation, we'll call this the top. I'm going to turn this 90 degrees, so this is the 9 o'clock position. Okay, so in the plug, or in the shell, that's 12 o'clock. We're now at this position here. You'll see a bunch of holes, I think 8 of them, a slot, and I hope you can see this little ramp here. The difference in height is maybe 0.5 millimeter. What happens is that this sidebar, I've never seen a lock with sidebars like this that are sort of, that move horizontally. So this sidebar is spring biased from this end, and in its resting position you can see that it sticks out and would bind in that groove in the plug. What happens is that when the key goes in and interacts with the ball bearing, and let's see if I can demonstrate that. So here's our key, which goes in this way. Okay, and the ball bearing goes here, I believe. Could be wrong, but we'll find out. The wrong sidebar. Okay, get that turned around the right way. This is fun to do. Okay, so we'll see that in the resting position, he's down. I think I've got him in the right spot, so we'll find out. So he'd be like that. The sidebar would be like this. Okay, and again it's up on the ramp, sticking out. Okay, did I have it the right way? Yeah. Up on the ramp, sticking out. Okay. Now, when we put the key in, and so he's not going in at this point, we put the key in, so you can see this. Okay. Hold that in. That ball bearing, if I pull this back out, you can see that he does not go in. Put the key in. How do I do this? Without totally blocking you. Okay. Put the key in. That ball bearing actually draws that guy in by engaging in this little hole in there. Now if it were lining up with any of these other slots, it would do nothing. But because this one is a little bit smaller and offset, it kind of pushes the bearing up, which slides this little bar back. You can see if the bearing were here, it wouldn't do anything, but if it is just a little bit offset and pushes up, it's going to slide that back just enough to clear the little ramp. Okay, that's the 9 o'clock position and the little ball bearing. So this is the 6 o'clock position. So in the plug, this would be here. Okay, or if you're actually have it mounted in a door, it's going to be the top, but I'm sort of working from the American standard. Now, he goes in, and now we're really looking at all these little cutouts here that I was talking about earlier. So the key goes in from this end. I don't know how well you can see, but there are places, all of those places where the little cutouts are, or those little dimples are, line up with some of these holes. So if I put one of these little T-pins in the wrong place, which is putting it anywhere is difficult, but the T actually, the flat part goes facing up. But if I put the T pin in a wrong hole, you'll see that he kind of sticks up just a bit, half a millimeter, maybe half the thickness of the top of the T. Okay, get out of there. If I put him in the correct location, and there are 4 of them on this key, and there are 4 T pins, profile pins, he goes down flush. You can see that pretty well. Okay, now, I'm not going to put them all back in at the moment. There is another sidebar. This one doesn't have any funny cutouts in it. It just has a little bevel on one edge, like most sidebars do. He lives in the slot, and you'll again notice there's a ramp. This is the back of the plug. There's a little ramp here. Again, that's like maybe half a millimeter high. So he sits down in here, like this, the spring. Okay. Now, if I put him in the right way, which I don't, there we go. Okay. Now, in his neutral position with the spring bias, you can again see he sticks out. If we slide him back off that ramp, if I can do that, there we go. He goes down and clears the sidebar groove. Now, what makes that happen? Okay, well, here's where that other pin comes in. So we have this pointy pin here. Let's see if that shows up in the screen here. Looks okay. Just twiddle the focus slightly. Okay, but he's got a little point on him. He goes down in this hole there. Believe I get that right. Oh yeah, the key's in, so it works. Take the key out. He falls back down. Okay. So now, when the sidebar is in place, again we have, he's not going anywhere, right? With his spring bias, he's sticking out into the sidebar, or into the groove. Okay, if I insert the key, this Saturn ring pushes that little pin up, which if we had the side of the thing here, by pushing him up, the ramp, or the little pointy bit on there, forces this sidebar back. So if I withdraw the key, he slides back forward. Remember, it can only stick out so far. So, I'm pushing in now, it's not going anywhere. If I insert the key all the way, now he gets actually drawn back by that pin sticking out. So when he pushes down, it can actually go somewhere. Normally he would catch on that ramp. Now, that's all great. So you have to set that pin. Okay. Then you'll also notice that if these pins are not are sticking out, they will prevent the sidebar from setting. So even with the active element, they're going to hold him out, and he's not going to be able to fall down into the little groove there. Okay. So that's the active element there. Now, so to pick this lock, what do we have to do? Well, we have to pick all of these security pins, and then at some point we have to go in and press the ball bearing in, which requires, if you look at where they are in relation to the plug, see if I can focus at this range. So the ball bearings are on this side here. Your key pins come in this way. And so you've got to somehow maneuver a pick in to hit the ball bearings. And to make life worse, and I don't know how well this is going to show up, but let's see. Let's see what I can do here. Let's get a little light. Here we go. You can see these little cutouts on there. Those are wards sticking down from the top, and those kind of get in the way of getting to those bearings. I guarantee you there's going to be one on the top. In fact, I can see where he would be. So you've got to get your pick in. I don't know exactly what kind of pick you'd use, but you've got to get your pick in here, right, and get one of those, find that bearing and press it out, and then hold the sidebar in place. And then, or at some point along the way, you have to get all the way the hell back here. Am I still in frame? Yeah. Get all the way the hell back here and push that up. Now, I have found that there is a trick for that. I get him out. And let's see if I can show you. The light again. So if you can, I don't know how well if it's focused, but if you can see there's kind of a little cutout right in there. Great. Goes back this way. And that's the tip of my pick is basically in that hole. I get there. So if you run your pick back, find this groove, and then pull the pick back out, so in and then out, you'll run over that pin and knock him up. And then again, that's behind all the stacks. Okay, so that's aligned sort of right here. Ish. Actually, it's dead center, so it's about here. So you've got to reach around, behind the stacks and get him down. Now the order, I don't know. Haven't figured that out yet. But, you know, we'll work that out, hopefully. So that is the DOM IX SR Saturn high security, and I'm not going to put any quotes around that at all, high security lock, gutted, and I think now I may understand enough to be able to pick it for you. I've been working on this one for a while. So there's the shell, there's all these little parts, the key, plug, and you can see the amount of machining that has been done on this thing. It's a lot of work that goes in there. It tells you why shows you why they're a little expensive. One other little thing, if you look at the shell, there's a hole here and there's a corresponding hole on the other side. We saw that in one of the other DOM high security locks, there was an active element that interacted with a pin down in the plug, the offset from the pin stacks. So it looks like they use the same milling process for multiple locks, which is not unusual. And then one last thing about this lock, since we've been doing all this measuring of stuff, let me switch to millimeters. Okay. If we measure the plug across sort of an area that doesn't have any cutouts, we get about 12.95 mil, which I think is 5100 thousandths of an inch. Okay, if we rotate around, we'll get a few different numbers. When it falls into some of these millings, it gets smaller, but that's about the max diameter along this thing. There's a 1296 in one little spot, maybe. If we measure the inner diameter of the plug and don't fall into any of the sidebar grooves, of the shell, and I'm falling into the sidebar grooves, of course. Measure the inner diameter here. You get about 1306 in that spot, 1304, 1305. So about a tenth of a millimeter, possibly, difference. 1293, 1306, something like that. Okay. That's in the sidebar. Oh, there's a 1290, 304, something like that. And that comes to 5140, 5130, depending on where you are. So it's about 10 or 0.1 millimeter, or about 3 thousandths of an inch tolerance between the plug and the shell. And there is a tiny bit of movement, but it's almost imperceptible. So that's not a whole lot of clearance to get all these funny pins set. So nicely made. And this is used, so you know, we don't know what it would have been factory new. So anyhow, DOM IX SR Saturn for the little ring in there. High security pin tumbler dimple lock. Anyway, thanks for watching. This is Alex. Hope you enjoyed this. If you like my videos, please subscribe to my channel. And as always, have fun and please keep it legal. Cheers.